welcome everyone. Thank you. Oh, make sure they're on mute. I just get some feedback on that. That's it, perfect. Thank you so much. So yeah, welcome everyone to March's Tutor Assessor Connections. Thank you so much for all coming along today. As it says there, you can have your camera on or off as we go through, but please mute your mic, and you can say hi in the chat with your name, role and centre if you like to get to know everyone that we've got along today. So contribute in any way that works for you. So if you've got questions, you feel free to stick your mic on, or you can pop them in the chat. Absolutely no silly questions at all. So anything that comes up, do just let us know. And yeah, absolutely, life happens. So if you need to leave because of the doorbell, pets, anything like that, then absolutely go for it. So the theme of this month's Tutor Assessor Connections is British Science Week. I'm sure, as you all know, it's coming up pretty soon now. So we've got a few different things we're going to go through for that. I'm going to do just a little bit of an introduction, and then we're going to have some presentations. We've first got Vary Taylor, who is an RTAV with the Young STEM Leader programme. She's going to do a little bit of a showcase about what some of her young STEM leaders have been getting up to. Then we've got Annie McRobbie, who works in circ biology, and she's going to be doing an experiment explaining red hair using a banana. And then we've got Ewan Mitchell, who is going to be doing some crystal growing experiments. We're going to have time for a bit of a Q&A with our panel, and then hopefully a wee bit of a group discussion at the end as well. So just a quick intro into British Science Week then. So this year it's a 10-day celebration of science, technology, engineering and maths, and it's run by the British Science Association. As I'm sure a lot of you are aware, it's taking place this year between the 11th and the 20th of March. The theme this year is growth. And one of the main activities that is part of the official British Science Week is a poster competition, which is also going along with this theme of growth. They've also put out some really nice activity packs along with this theme, with loads of nice things that your young STEM leaders could get involved in. Some of the kind of themes that they have suggested exploring along the theme of growth would be things such as could your young STEM leaders or whatever young person is taking part do something to do with a tadpole's journey into being a fully grown frog, or very relevant how a virus spread in a pandemic, and what do we mean by exponential growth, or how does the growth of consumption affect the planet, or just some of the things that would fit in with that theme of growth. So there's a poster competition that your YSLs could most definitely get involved in, and there's activity packs there's separate ones for early years, primary and secondary, including activity ideas on how to get involved in British Science Week. Loads more activity ideas that would fit in with the theme of growth on the STEM Learning website as well, so I definitely recommend checking those out. And along with the theme of growth, the British Science Week have also put out a Smashing Stereotypes campaign. So there's lots of different videos that they've put out to showcase different people in different professions, so that would definitely be something that would be great to share with your young STEM leaders when you're looking at the stereotypes sections of the programme. So that's just a wee bit getting us started on British Science Week. So I'm going to pass over to our first speaker now, who is Vary Taylor, and she is going to tell us a bit about what her young STEM leaders have been getting up to. So I will pass over to you, Vary.
Hi folks, just going to check, can you hear me okay for sound? Yep, we're good.
Yes, I can hear you.
The signal at Stuart and as Jamie will flag up is extra special at times. It's like we're so rural, it just shuts us down completely. We have got a kind of wealth of experience with British Science Week. We started off delivering British Science Week as our school's journey into accessing the STEM curriculum. From there, we've kind of evolved. We moved from March in the last years pre-pandemic because we felt that March was SQA heavy. So we kind of took the British Science Week packs and we run them in November, but it's just something that we look to do at academic level so that we could give it as much value as it was worth, because there was so much there to do. Our experience currently, we have got young STEM leaders at level 5, 6 and 2. We have moved to a kind of scaffolding model this year, which is the first time we've ran it that way. Traditionally, we've had our tutor assessors being our teaching staff or our NQTs. This is the first year we've got our level 6 pupils are targeting and working with our nurture groups, and they are working with now our primary 7 transition. They had looked at the growth slides. The only thing that they kind of struggled with, they were looking for fast, quick impact experiments, but they have been able to pull a few. So sometimes it's about being a wee bit creative and thinking outside the box. So they started this week delivering the Discovery Badge. I've got a little animated clip of them sitting delivering. They've generated their own work, their own PowerPoints, and they're talking to 170 S1 or primary 7 coming into S1 pupils. We could actually employ them as staff. They are that good. So I'll give you a wee clip of the video to show how they've done that. They're building up obviously to go out to primaries in 2 weeks' time to deliver the create aspect of the badge. So they're going to go out and deliver the slime activity from the British Science Week pack, because they got something that the pupils would take to. I'm not so sure about the primary 7 staff members, mind you, but they know it's an activity that will engage them. They can talk about the health and safety risk with it, which would cover the kind of outcomes at level 4 and 2, and it gives them an activity that they can also take away. Thinking outside the box, though, when you're looking at the kind of aspect from British Science Week, they've also considered, and they've delivered in the last few weeks, activities to build structures. So they've linked that to growth. So they've done the really simple activities, something simple like using the gumdrops, using your toothpicks, and they've either limited the resources, or they've given the resources a cost when they were working with the nurture group. So they tried to differentiate the activities to make it not too long, but to also try to challenge people so that they're actually being pushed. The other thing they've looked at and they've went out and invested in is do you know the thermal covers for your copper piping for your heating systems? So they've got a whole range of these that the techie department have cut in half. So for growth, they're going to look at an engineering challenge going forward, and they're going to use it as a marble run. So we've set up like a classroom space. So they're going to bring in different teams to try and see how big they can make the roller coaster, and can they get a loop system working, and using a marble, can they get it to go around the loop? So it's really interesting to see their perception of how they can deliver the level 2 award as a level 6 ambassador. We've further linked that in to a small cohort of National 4 Science pupils. They've kind of came to the end of their course, so in March they have now started the level 4 Young STEM Leader Award, and they're going to be working with our level 6 Young STEM leaders to go out on these primary visits. So they'll be showcasing an experiment as well along with the level 6, and it also gives them a chance to work together. And they're both coming from completely different aspects of the spectrum, in the sense that the National 4 Science pupils aren't really academic. They've got a love of science, but they obviously don't have the academic level or ability that our Young STEM Leaders level 6 do. They're our advanced higher pupils in S6, so it's really lovely to see the S6 advanced hires working with the kind of lower year groups as well as one big team to go down to the primary. I think it's also quite nice in doing that model so that the primary 7 pupils can see that they don't have to be the most academic pupil in the class to take part in those activities and also to progress with it. So it's always about thinking outside the box, and it's also considering what levels are in place and how could you actually showcase them to their best to make sure that people can perceive that it is accessible to all. It doesn't come down to literacy or numeracy, it's just a general love of science or STEM sector career pathways, and try to engage that way. But if there's anything else, there's lots and lots of wee ideas. We have also used a maths challenge or maths in the box, and we've had older level pupils go into S1-2 classes to try and push on numeracy, especially the lower sets that maybe find numeracy quite a struggle for them. So they've looked at hands-on numeracy activities rather than it being the more traditional chalk and talk that took place. We have had boys in physics that are academically, that are really into PE, they're really into sports and coaching and leadership. They looked at the physics of football with Arsenal Football Club. There's a kind of resource there. So with the theme of growth in British Science Week, it's there and it's in the booklet, but if it doesn't fit, go outside the box and think about how growth might fit in your curriculum and what the pupils actually have a skill set in. What is their perception of growth? Because I've tended to find that what I think and what they think don't always marry up, and they come out with some massively beautiful ideas of how they would like to undertake the challenges. I'm not going to talk about our crystal growth over Christmas because I know that's coming up next. That went really, really well. But there are just lots and lots of wee themes and ideas. It's not about trying to add to your curriculum. It's about seeing what's lying in your curriculum, what's maybe missing from the curriculum, and building what already exists. That seems to be what's worked really, really well for us. Tying it into curricular pathways as well. We've now got 6 or 7 staff trained as tutor assessors because the capacity for growth and its place within the curriculum can now be seen by staff in other departments. So that's brought our buy-in. Rather than me going about trying to flog a horse of, oh, we need a few more, people are starting to see it offers up another scope. It offers up more tariff points as well, which is always goes down well when you're talking to your senior management team, that these extra tariff points, some pupils you will have in front of you, that they then will be able to access these additional levels. But for activities, go as wide as you want. There's lots and lots of resources there, but I'll add into the Teams group kind of a Word document of things that we've done and how the resources we've tapped into, so you can see it, and I'll also add the wee video of our level 6 and the PowerPoints and the showcase of the work that they've done as well to deliver for this level 2 programme. Okay, Laura, have you got any other questions or ideas you'd like me to cover with the group?
Fantastic, thank you so much, Vary. I know you need to get going, so if the group have any questions now, feel free to raise your hand for Vary, or you can just stick your mic on. So that's not for this. Do I see any in the chat there? No, not yet. Okay, no worries. It would be really, really great if you can add everything into the... Oh, is someone asking a question? Sorry.
Yeah, can I just ask a quick question? See your S6 young STEM leaders and your S4 Nat 4 one, do you teach both classes, or do you go into somebody else's class who teaches the Nat 4 and work with the kids from there? I was just wondering how you coordinate it yourself, or if there's another staff member involved.
Good question. So I teach the level 6, so I've got my 4 levels, and there's another teacher that I just trained up last week as a tutor assessor who already had the science class. So we've worked as a dual. So I've popped in, and obviously I'm training Drew up as I go. So Drew's been working with the National 4 Science Club, but the S6 have also been in. So the S6 pupils in their kind of free time have also went in and kind of timetabled it to look at when they're off and when they can offer a support. So they've also went in and supported as well.
That's fine. So there's you and another member of staff basically involved in doing it. That's fine. I was just wondering if it was your own class you were working with, or if you were working across the department with it. That's great. Thanks very much, Vary.
No, not at all.
Sorry, can I ask a question, please?
Yeah.
Yeah, I'm probably jumping the gun a bit here. I've got 3 P7s that are organising whole school science activity for British Science Week next week. I am a tutor assessor, and I've just they've just pulled it together in the last 2 weeks, but I haven't managed to get their profiles sorted yet, and I'm not sure which level. I'm probably way ahead of myself here. I'm not sure which level I should be attempting to get them signed up for, etc. I'm a bit sort of... I was in the meeting last week, but unfortunately I got pulled out of the Teams meeting to go to another meeting, so I only heard half of that. Could someone help me with that at some point during this call, please?
No, they definitely could. I would probably go for the level 2. Unless you feel that as 3 primary 7s, if you think they're probably in the top 20%, you potentially could push for the level 3, because as a tutor assessor, the workload for yourself isn't really, there's not much of a difference. It's the same declaration form, etc. you'd be filling in. But if you feel that there's maybe they're slightly more academic, they can maybe push for the level 3 for them.
Yeah. Sorry, yeah, they are quite academic. They're sort of quite high flyers. They've basically picked one of the activities from the pack for the upper school, and they've adapted one and chose their own activity for the lower school, and they're going to go into each class and basically show a short PowerPoint, talk about it, and then help them do the activity and then fill in the findings afterwards. So they are quite, they are quite out there in terms of what they're going to do with it.
Yeah, so potentially I would probably push for the level 3. What really comes, as Jamie will back me up on this one, is they all have four badges, but it's just the theme is slightly unique. So I would think, Jamie, can you confirm that level 3 is looking more towards the careers sector within STEM? It kind of maps out what level 6 is. It's more towards leadership. Jamie, can you confirm?
Yeah, that's absolutely right. And I was just typing a message in the chat just now, but I would agree to go for it, be ambitious, go for level 3.
Yeah.
And that also opens up opportunities for younger pupils, so primary 4, 5, 6. If you wanted to offer a level 2 to those pupils in the future, that provides a nice progression towards through the award as well. So yep, I would agree.
Yeah,
well, that's a good idea, because this is the first year we've done it, and we're all finding our feet, and I would like to improve it next year. So that's a really good idea. But anyway, I better let you crack on with the presentation. Sorry, thank you.
Not at all. Thank you. Thanks for your question.
No worries, fantastic. Yeah, it's great to hear your questions. I think Valerie, you've got to dash off now, but yeah, if you could add that stuff to the team, that would be fantastic. And if we've got more questions as we get towards the end, I'm sure other speakers will be able to give their opinions as well. So thank you again so much, Valerie. Next, we're going to be moving on then to welcome Annie, who is an education manager in biology here at CERC, and she's going to do a wee presentation. So I'm going to stop mine, and I will hand over to Annie. Thank you so much.
Hi there. Yeah, I'll just try and share this. I've got a video as well with audio on it, so I'll try and just put sound on just now. I'm not sure if that'll cause a problem.
Should be okay, just if you've got that wee tab thing. I think
right,
that should be fine.
I'll go with that. Right. I'll change that one. Okay, does that look okay, Laura?
Yeah, that's looking fantastic.
Right. Hi, everyone. I fairly recently moved to CERC from Wallace High School, where I was a biology teacher, and whilst I was there, I did the Young STEM Leader programme as well. So I was asked today to come up with some like a simple experiment that pupils could lead during British Science Week. So I've got a few things to show you. So the first thing is actually another thing that I've built around British Science Week that we're going to do next week with STEM ambassadors. So this resource will be released too, and there was a number of different experiments there. I'm just going to minimise that so you can see it. Working with things like merge cubes, microbits. There's a debate that pupils could lead as well. That's about and all of these things are about the brain and how that changes over your lifetime and how that grows as you age. So there's a number of different activities that you could tap into there as well, which have been specifically chosen for pupils to lead. So for example, everyone should have microbits in their school. It's trying to find out where they went to when they were originally sent out. But there's one here where pupils could lead an activity looking at reaction rate using microbits. So there's lots of cool little wee things in there where they could do a bit of coding and then actually carry out the reaction experiment with a number of different pupils. So that's there as well. But the one that I decided to go for today, because I was asked for an experiment, is this one. So how could we turn this into being about growth? So it gets a bit of a tenuous link at times, but I think that if anything is about enzymes, it's about growth as well. So it's a little bit like Laura said at the beginning and what Barry was saying. It doesn't necessarily have to be really obviously about growth like plants growing. So this, if you wanted it to link within your curriculum, this would be a nice experience and outcome from the BGE, where we're just looking at the use of enzymes and how they're involved in different processes. And I picked this one because this particular enzyme is involved in a whole range of different processes that are all to do with growth. And one of them is actually how come some people have red hair. Now, it's not quite simple as that, but it is one of the reasons, one of the contributing factors for people having red hair. So the reaction that we would be looking at is taking this substrate here called L-DOPA that a lot of schools will already have, especially for the upper end of the school, and using this enzyme here called dopa oxidase, you produce this product here called dopachrome. And the reason it's linked to red hair is because dopachrome is red. So it gives rise to the fabulous redheads. But it's also involved in loads of other interesting pathways that your young STEM leaders might be interested in. So when you actually look at in the context of metabolism, we've just looked at that reaction in the middle, but they might be interested in this part here. So the conversion of L-DOPA to dopachrome also means that you get rid of this process here, this molecule phenylalanine, which is one of the processes that they check in the Guthrie test with newborns. So if you know that that enzyme isn't quite working well, then this could be a problem here. It also feeds up into the production of melanin, which could go some way to thinking about skin colour and also the colour of hair, general pigmentation. And another final pathway that pupils might be interested to use this experiment to talk further about in terms of growth is this one at the bottom, which is about how dopaquinone is involved in the production of dopamine, which is involved in your brain's neurochemistry and has a link to the development of Parkinson's disease. So just by looking at this one reaction, you've got this whole context of metabolism that feeds in, and we're just looking at a tiny wee bit, but it can explain loads and loads of different processes, and depending on what your pupils' interests are, then they can hook into different parts. Okay, so all you really need for this experiment is this stuff here. So your enzyme comes from a banana. You need the L-DOPA, which a lot of schools already have, and a lot of the time any teacher that's come to CERC will actually have a supply of L-DOPA given back with them as well. You need a cup and a fork, a test tube and a couple of pipettes. So instead of going through the process like that, I'll just show you how simple it is for pupils just with a couple of ingredients to lead that experiment across the class, maybe go into a junior class, and I'll show you what some of my pupils did with an experiment to show you what they could do in terms of a transition project. So someone might have to keep me right here, make sure this sound's working okay. Let me find the right window. There we are.
Hi there. I'm going to show you.
Is that okay, Laura?
Yeah, we can hear you.
Perfect.
Quick experiment that you can do or get your parents to do during British Science Week. And this is a really simple, straightforward enzyme experiment. And it's really great because it shows that enzymes are found in living things, even something like a banana. Okay, so you just need a few wee things. So we've got a test tube rack and a test tube. You're going to need some water. The substrate for this reaction is L-DOPA. So this was the L-DOPA powder, and I just dissolved it in water. A fork, and then a beaker or a cup and a pipette. So I'm just going to start by taking just a really small amount of the banana, so probably about that much. And then you're just going to mash it up. And then just keep adding water to that. So you don't want it to be too, you can have it quite liquidy. And you're going to have to be able to use a pipette to extract some of the liquid from this. And if it's too ropey, it doesn't work very well. So add a decent amount. Further up the school, you might use a centrifuge and just get the actual liquid portion of this. But actually, this works fine, as you'll see. So I think that's okay. So you can maybe see how runny that is. It could probably be a little bit more. just to help pipette it. So just give it a good swirl round, and that's it. And then into your test tube, just take a small pipette, and this is the substrate, so this is the L-dopa. And depending on the volumes that you want to use, or however much you've got, you could get away with 1 ml, 6 ml. It's not a particularly fussy recipe, this one. So that's your substrate in. And then we'll get a clean pipette, and you've got to now extract some of the banana liquidy stuff. So if you had centrifuge this, you would have the supernatant, and that contains the dopa oxidase enzyme. But when it's like this, you'll find it's quite difficult to pipette. So just go to the edge and try and extract some without getting bits of banana in it. So a wee bit there. Again, it's not particularly fussy. And then, so this is the substrate in the test tube, and this is the enzyme in the pipette. And you can see it's completely clear. And as we add that enzyme in, very quickly, it's going to change colour, because we're going to have a reaction that produces the product dopachrome. And dopachrome is something that, as we said right at the beginning, is involved in making your hair red. So I probably have quite a bit of this. And you'll see quite quickly, it's really good if you hold up against a white background. We put it here. So within about 20 seconds, you can see that there's quite a lot of dopachrome being formed. And this reaction here is part of a wider range of metabolic processes.
Right, I think that's probably all I need, because then I think I just go and say more of what I've already said already. So let me go and put that back up. So yeah, with very few bits of kit, your kids can lead that experiment, no problem. The only thing you really need to source from your school, other than these normal things, would be the L-dopa. The other thing that's really nice in that experiment is you can look at how lots of natural things can inhibit that reaction. So weird things like green tea will slow that reaction down, and people can think about the wider implication of things like that as well, how different parts of your diet might actually slow down some of your metabolic processes. So I put this together just to think about it in terms of the young STEM leader, the different badges. So for Discover, they could look at the role of enzymes in general, about different processes. So for example, influencing your hair colour, your skin colour, or development of certain diseases. They could then create an activity for younger learners to understand that enzymes are found in all living things, even bananas. And they could do lots of things like sharing it through the science faculty website, or however you put out information from your school. And then the lead part is that they are leading that across the science faculty. And to show you how I did something similar to that, I didn't use that exact experiment, but when I was back in Wallace, I had a wee group of third years who were pretty able kids, but they just loved science. And it was during lockdown, and so the P7 pupils couldn't actually come up to the school for their normal transition. So they put this website together where they did little experiments, filmed them. So for biology, they extracted DNA. Physics, they did the refraction of light. And for chemistry, I think they did, they did burning magnesium. So that was another fairly straightforward experiment they could do. And then they built this little website, which I've loaded up, I think, already to show you. Oh, maybe not on there. I do have it somewhere, promise. Okay, I can share it somewhere else just to save a bit of time. But that was a really nice way for them to show all of their bits and pieces of information. And I'm going to just come out of this just now because I've gone and lost my screen now. Let me see, where have I put you? So yeah, that was a nice way for them to share the information that they'd done in their experiment as well. So I don't know if anyone's got any questions about that you want to ask me.
I think what we'll do, Annie, is we'll move on. Oh, Jamie's got a question. Okay, go for it, Jamie.
I'm so sorry to interrupt. It'll be quick. That was so interesting, Annie. Thanks so much for sharing that. Now, I just wondered, obviously we have a lot of primary tutor assessors on the call. Some of that might be slightly beyond primary learners. Is there a way that you could investigate similar concepts with a primary group?
Yeah, you could, because I can come up with something similar, like a similar experiment that you could do that didn't involve as many complicated. Yeah, I'll come up with a similar thing. But lots of things in that first thing that I was showing you with the brain activity things, lots of things in there would work as well, like the reaction test. If you have microbits, I'm not sure how many primary teachers have access to those. But I can have a think about an enzyme experiment, because sometimes the substrate is actually really easy to get hold of as well. And then you can just do things like mashing up a potato and then you've got your enzyme. So I'll think of something.
Oh, you're too good, Annie. Thanks so much. Thanks for that presentation.
That's okay.
Yeah, that was so cool. So thank you so much for that. Oh, can everyone still hear me? I can't see everyone now. Aha, there we go. Okay, fantastic. Okay, yeah, thank you so much, Annie. We'll hopefully have some time at the end for questions for both yourself and Ewan, who's coming up. But we'll move on to you now. So I won't bother sharing my screen again because you're just about to share yours. But anyway, this is Ewan Mitchell, who also works at CERC in early years and primary, and he is going to demonstrate another experiment over the theme of growth.
Yes, I will do if my computer behaves for me. Hold on a sec. It's all right. It all worked so well. Sorry, I'm just going to share my whole screen. It seems to work better.
Oh, I can see multiple versions of myself, which is always terrifying.
Can you see that okay now, though?
Yes, I can see your presentation now.
Excellent. You might not be able to see me. I don't actually know how all this works, but anyway, so yes, so just because British Science Week coming up is on the dates from the 11th to the 20th of March, thought it was a good time to obviously share or be involved in this Tutor Assessor Connection about showing how to grow some crystals in the classroom. So this is going to be a great opportunity for you to show a practical STEM activity that's simple, easy to do. It's always going to have success. Each learner will have different successes, I suppose it has to be said, but it will also raise awareness of science inquiry within your classroom or in your setting. From nursery all the way through to P7 can take part in this activity. And again, it will be great to see your young STEM leaders being able to take this activity forward with other learners, leading learners within your own settings as well. So we're going to look at salt crystal decorations, focusing on dissolving and observation over time. Obviously, this does fit maybe better into certain times of the year, but I mean, who wouldn't like to, for instance, make a little salt crystal rainbow or a decoration to go in front of a card or something like that, rather than having to be a specific decoration around Christmas. Obviously, it can be themed. Easter's coming up around the corner. You're all imaginative and creative, so I'm sure you can think of something that it can be used for. Before I go through the actual activity, just a bit of health and safety advice about growing crystals. So for early years and primary in particular, obviously not maybe quite so much for up in well, Annie or the other secondary education managers at CERC would be able to provide secondary health and safety advice, but certainly for nursery, early years and primary, we advise only using table salt or sugar. Sugar being obviously much stickier, so table salt is far better and does give you exactly or pretty much the same results. Unfortunately, the internet is not always our friend when it comes to Googling or looking up these kind of activities. And you could be taken to either American websites or YouTube, where they suggest using either borax powder or copper sulfate for crystal growing. We would never support or provide any guidance for the use of borax powder in early years or primary settings, and certainly not any copper sulfate for safety reasons. However, strangely enough, when you do look to buy the pre-prepared packs in the various different shops that you get, then you will often find copper sulfate in there. But again, if it's being used at home, then that's up to the parents to make that decision as to whether or not to use them. But certainly in classes and in education settings, please don't. And if you've got any questions on that, please do give us a shout at CERC. So the salt crystal decoration or salt crystal activity requires these activities that are on the screen here. You do not need a universal tube. We created this activity for use when we were providing resources to a local authority. And we provided the universals. You can just have a teaspoon or a tablespoon and a little balance as well, rather than actually having that there. But the other things, as you can see on the screen, are easily obtained in your settings themselves just now. We always like to make sure that we're giving the teachers or the educators a bit of CFE links, and I know that the learners certainly like to know where it fits into their learning as well. So following the line of development 16 through first level and then into second level, you can see that it shows and speaks about dissolving. And I know that, and predicting and investigating, and I know that in schools and education settings across Scotland, we always like to make sure that there is real life examples of this as well. And you can see moving into second level, the variables that can be included, which can be the different temperature of the water, as well as the various different time scales that you can put into, or the number of stirs that you take to try and get everything dissolved in there. So I've used the word dissolving a couple of times. On the right hand side of the screen there are other scientific vocabulary or scientific words that we would want the learners to be able to use and to use appropriately. And when you're talking about dissolving, if you ask the children or the learners, sorry, where has the salt gone when you add it into the cup of water, 9 times out of 10, the first answer that they will give you is it's disappeared. And that isn't scientifically or technically correct. The water, the salt has obviously dissolved into the water, and then that can be shown by you actually weighing the cup. So weighing the cup with the water in it first of all, in your digital balance to show what the weight is, adding in a certain amount of salt, stirring that to allow the dissolving to happen, and then that weight has changed. Even although the salt is now no longer visible in the cup, we know that it is still there, suspended in the solute. So what affects and how quickly something dissolves is obviously something that you can get the children to discuss, to investigate and to look at, and that can be the changing or the variable changing of the water. So some groups in your class could have cold water, others could have tepid water, and others could have as hot, hand hot as you can get from your tap in your classroom. I know that in some settings that is limited by the local authority, but that just gives you a little bit of a variable, and then you want to try and dissolve as much salt as possible to therefore make a saturated solution of table salt. This PowerPoint is going to be shared. I've shared it with Laura already, its location with Laura and Jamie, so they can pass this PowerPoint on to you so you can have this for reference later. So you take roughly around about 200 mils of as warm water as you can possibly get from your taps. 50 degrees is absolutely perfect, and that can be kept in a thermos flask or a thermos cup until you're actually requiring it. And then you're looking to try and dissolve as much salt as possible into this solution. The best way to do it is a bit at a time. So you can also get the learners to weigh out 20 grams or so of salt at a time, and then in a different cup, and then to pour this in. So you're working together on this activity. Once you've dissolved as much salt as possible, How will you tell that that solution is absolutely saturated? Well, you will start to see salt just staying at the bottom of that cup. No matter how much you try to stir that, and no matter how vigorously you stir it, there will always be some salt left at the bottom. That way you know that that solution is completely saturated. There will be no more dissolving happening in that cup, even if you leave it overnight. That is called a saturated solution. So once you've got your saturated solution, you then need to think about what you're going to cover in that saturated solution. No guesses for what time of year we focused on when we were delivering this. So yeah, Christmas decorations came to mind. So you need to cut out the different, well, I said paper, but it's actually, it really needs to be card for it to hold its shape and to be able to withstand being completely submerged in some salted solution for a period of time. And this is where you can actually bring in some maths links where they're measuring, they're looking at symmetry as well. And then this is the point where if you are going to have them as hanging decorations, you need to hole punch the top so that you can then thread or put the thread through once they have actually dried. So once you've got your shapes and your solution ready, you can add in some food colouring, which is shown in the top picture here. However, bear in mind the risk of food colouring on certain items of clothing may not be conducive to learners using it, depending on the age and stage that you are working on. And if you don't add food colouring, the activity is equally as impressive and successful. So you need to place your shape down on a paper plate, or a plastic plate, or a polystyrene plate, or a ceramic plate, any kind of plate that you want. You can actually even put it, if you've got a nice flat surface, you could just put it on top of maybe a Polly Pocket on as long as there's a little bit of a dip. So Polly Pocket, you don't want to empty the entire contents of a cup across the Polly Pocket. And pour the salt solution over there to make sure that you have completely submerged the bit of card. Try to make sure that you don't pour too much of the granules at the bottom of the cup in. However, one or two seeping out isn't a bad thing. It does give it a starting crystal basically to start growing. Oh, sorry, I'll just flick back. You can then discuss with the learners where they want to put theirs to therefore then dry out. So we're looking for evaporation. So the water will evaporate, leaving the solid behind, which will also therefore then gather on your cutout shapes. So you might want to have 3 or 4 different areas in the classroom, and therefore you can actually then observe over time to see what is happening in each of these areas. Maybe windowsills where you're going to get some light, then somewhere else in the classroom where it's maybe not so warm. I would advise against putting on top of the radiators in the classroom, purely because the evaporation happens fairly quickly and therefore doesn't give you quite as good a result. A long, slow evaporation process gives the best results here when it comes to the formation of the crystals. We talked about adding a bit of food colouring in to your saturated solution, and it's another great observation activity. So if you had your 2 cups, one just with the water from the tap and the other one with the salty saturated solution, it's a fantastic way of looking to see what the difference is when you add that food colouring into the top. It's also a great opportunity to involve some digital technology, taking some videos, taking some photographs, and even setting up a bit of a time lapse to see how see the progress of the food colouring dissipating through the liquid, and also for your creations of your salt crystals. So there's lots of questions that you can ask, and these don't always need to be related to this activity as well. So what happens to the water? That can also be linked to just the playground, a puddle in the playground where the children draw around the puddle, and then at break time, lunchtime and at home time, they have a little look to see what has actually happened, and they see the shrinking of the puddle, and they continue to draw the chalk line as well. Here, what they should start to see is that the water starts to evaporate, the water starts to get less on a daily basis. And if you have food colouring in there, the food colouring starts to look a little bit darker. These are the 2 pictures of what we've created there. So what will happen to the salt? Well, the salt, because it was suspended in the solution, will therefore then start to form as crystals once again. This is a great opportunity for you to get either hand lenses or digital microscopes out as well, if you have such things in your settings, and get the children to have, or the learner, sorry, to have a look at the salt granules before it is dissolved in comparison to the crystals that they have left here. It is very, very cool to have a little look at these. The talk here is, I suppose, is that the salt that has been suspended in that solution is now on the plate and on the decoration. Some of the salt will have evaporated slightly, but the majority are here. And here's a close-up of our crystals that have grown or have developed on the two cutout shapes. You can see the one on the right was green card that we used and no food colouring. The one on the left was actually just white card with blue food colouring. So you can see the differences there. Some other ideas for you to grow crystals in your class don't always have to be on just bits of paper. You can have a pipe cleaner, which I know there are a plethora of pipe cleaners in art and craft cupboards all across Scotland's schools. You can have them suspended from a straw or a lollipop stick across the top of a cup. So once you have created your saturated salt solution, then have that dangling into your solution, and over time, as it evaporates, you will see the crystals forming all around these different shapes that you can have created. And again, just provides another talking point and another opportunity to investigate the development and growing of crystals. And that is me. Short, sweet, to the point, but hopefully provides an opportunity for you to be able to have a little investigation or play in your settings.
Yeah, absolutely. I think both of those experiments look so visually lovely, don't they? The salt crystals and the red hair banana experiment. So we've got some time for Q&A now. And I know that Annie had maybe come up with an answer about how to make the primary enzymes a bit more primary friendly. So maybe start with that question to Annie, if you wanted to answer.
I don't know if you've ever done this, Ewan. I'm not going to be very good with the whole primary thing, but I was just thinking of something that they could do. I've done this right up at advanced higher as well, but you can have jelly, which contains protein like gelatin, have it all set, and then you can pour in pineapple juice, and pineapple juice contains an enzyme called bromelain, which actually breaks down the protein. So just with a couple of ingredients from home, you could show an enzyme reaction breaking down protein and link that to how enzymes in your own stomach would work to break down protein in food and therefore allow you to grow, if we're going to stick with finding a growth theme. But I think that would work quite well, and you can just pour, even if you just made your jelly in a plastic cup and poured on the pineapple juice on the top. And then you can even do things like you can boil the pineapple juice, and that wrecks the enzymes, and then it doesn't work. And if you use tinned pineapples, it won't work either, because they've been treated in a certain way to store them. So don't use, it has to be fresh. But that would maybe work for primary.
Yeah, that sounds like a great idea.
I can write it all down. I can figure out numbers and volumes and things if that helps. But that would be a quick idea.
Yeah, I'll share both your presentations so that people can refer back to them. So if you've got any other bits like that to add, we can share that as well. Brilliant. Did anyone have any other questions then? Anything else for Annie or for Ewan as well? I'll just check the chat, but it doesn't seem to be working for everyone. So if you're happy sticking your microphone on. We've got someone saying, can you share the hour growing brain activity again? Yeah, absolutely. I'll put everything in the Tutor Assessor team, so you'll be able to refer back to everything. Yeah, fantastic. So does anyone have any other questions before we move on to the next part of today?
Or how do you get access to the Tutor Assessor team? Because I don't think I've got that.
Aha, now that is a very good question for Gail. Gail, are you able to answer how the best way to access the team?
Sure, I've got a little video that shows you how to go up to your avatar on Teams, and then you have to select, because we're a different organisation from yourself, but I'll send it to you. Can I just check who it is that's asking?
Oh, sorry, hang on, I can see SRC CERC guest.
I think
Diane
Diane
was asking. Yeah.
I think Diane just switched on to CERC to access the team, and it's booted her out of the call probably.
Okay.
Oh dear. Okay. Well, we will definitely get that information to her then. Excellent. Does anyone else have any other questions before?
Yeah, sorry, I didn't realise there was a Teams for this. So can I get on it as well, please?
Yeah, absolutely. Yeah, we've got about more than 500 members on the team now, and it's just somewhere where it's really great that we can share resources like this, and I put announcements in of events coming up like tutor assessors and that sort of thing. So yes, we've got a little video that explains how to get into it, and what I'll do is I'll share it with all the participants on this call afterwards via email, and then hopefully you can all get into the team.
Yeah,
Brilliant.
Hi Laura, sorry,
Yes.
I hit the button to switch me, not realising it would actually take me out of the meeting.
There, I think maybe it booted you out. No worries.
Yeah.
What I'm saying there is just we'll share with everyone how to access the team by email. Everyone that's joined the call. So for the last 5 minutes, then I'll just pop my presentation back up. As it is Tutor Assessor Connections, I thought it would be really nice if we could, let me just go through all these, really nice if you could meet each other as well, rather than just hearing from us. So I was just going to pop you into a few breakout rooms and just get a little bit of discussion going. What are your plans for British Science Week? Do you have examples of the activities that your young STEM leaders might be leading? And if not, what is the most successful activity that your YSLs have delivered? So just really be nice to get a little bit of discussion going about what the kind of most effective and most successful activities that you have found with your young STEM leaders have been. So I think Gail is going to pop us into some breakout rooms just for 5 minutes.